take a look at this example. W is the region, the first octant bounded by z is equal to 4 minus y squared. Z and x are both equal to 0. Y is equal to 2x. Write down iterated integrals for f of x, y, z as x times y times z in these 3 different orders. We know there are 6 possible orders. We're going to do these 3 orders here. Okay, before we do anything else, let's draw a picture to get a sense of what's going on here. Okay, so y is equal to 2x. Okay, that is this line coming here in the xy plane. And z is equal to 4 minus y squared. In the yz plane, this is going to be a downward opening parabola. Okay, then this is, so where is this going to intersect here? At z is equal to 4, at y is equal to 2. And then this z is equal to 4 minus y squared, that just kind of gets translated as we move in the positive x direction. So the other top here, it looks like this. So it is this kind of wedge-shaped region, triangular base, curved ceiling, curved roof here. This is the region in question we want to integrate over. Okay, so let's start off here, dz, dy, dx. So first we integrate with respect to z, then respect to y, then respect to x. We want to think about projecting this region, this 3D region, into the xy plane. So the region that we integrate in the xy plane over is, the thing I'm putting these green dots in down here, this triangle down here. So what do we end up with? dz, dy, dx. Okay, x and y. This triangle in the xy plane has 3 vertices. Of course, triangles have 3 vertices. This point right here is 0, 0 in the xy plane. This point here is x is equal to 0, y is equal to 2. And then this point here, y is equal to 2 times x, and y is equal to 2. So this would be x is equal to 1, y is equal to 2. So we have this triangle here in the xy plane. This line here is y is equal to 2x. So now we need bounds on x and y and z. Okay, so what happens here? So x bounds, we want the x bounds to be constant. We can see x can be anything from 0 to 1. Our y bounds here, y has to be in terms of x. So y can run from 2x. At least the lower bound here is y is equal to 2x. The upper bound is y is equal to 2. As for upper bound, now for z here, we want to go back to this picture. So for a fixed value of x and y, z can go from 0 to the ceiling. The ceiling has equation z is equal to 4 minus y squared. So this gives us x runs from 0 to 1, y runs from 2x to 2. I'm just copying this stuff down here. Z runs from 0 to 4 minus y squared. The function or integrand was x, y, z, dz, dy, dx. So let me just point out here, the outermost bounds must be constants. The y bounds here can depend on x. This one does. The z bounds can depend on x and y. So far, so good. Okay, 1 down, 2 to go. Now our next choice here, dx, dz, dy. Okay, so now we need to project into the the YZ plane. So this region right here is the projection into the YZ plane. So there Z is 4, y is equal to 2. This is Z is equal to 4 minus y squared. So in this order, y needs to have constant bounds. Z bounds can depend on y. X bounds can depend on y and z. Constant bounds on y, we can see this is going to be y runs from 0 to 2. Bounds on z for fixed value of y, z runs from 0 to 4 minus y squared. Okay, and then now we need to think about what are the bounds on x. So for a fixed point in the YZ plane, this is when x is equal to 0. And then we go until we hit this surface right here. This point is in this plane. And this plane is corresponding to y is equal to 2x. So right here, this is y is equal to 2x, or x is equal to y over 2. That's going to provide us with our upper bound on x. So what do we have? Y runs from 0 to 2. Z runs from 0 to 4 minus y squared. X runs from 0 to y over 2. X, y, z, dx, dz, dy. Y bounds, outside bounds are constant. Z bounds can depend on y, but can't depend on x. X bounds can depend on these. Okay, so 2 down, 1 to go. Now we need to do the order dy, dz, dx. Okay, so in order to do this, we need to figure out what is the projection of this in the xz plane. We need to figure out what does this look like when we take this region and project it into the xz plane. What does this look like? Because right now there's nothing, I just drew this, that is what the projection is going to look like. This is going to be, we have to describe this projection here into the xz plane. Because once we do that, the y is going to go from this to here. Well, let me start writing this down. In this order, x will be our constant bounds, then z, then y. We can see that the biggest y can be here for fixed, this set of x and z. The biggest y can be here is on this surface right here, which is the z is equal to 4 minus y squared. But I have to rewrite z is equal to 4 minus y squared. I nearly wrote down y is less than or equal to 4 minus y squared. Now we need to invert this to get y in terms of z. This is y squared is equal to 4 minus z. Take the square root of both sides, y is equal to the square root of 4 minus z. Note, we don't need the plus minus here because we're working in the first octant. So upper bound here is square root of 4 minus z. For the lower bound, it's this surface right here. So this is corresponding to y is equal to 2x. Okay, so we have the y bounds. Now we need to think about this picture in the xz plane. What is going on here? So first thing, the biggest z can be is 4. So let's make a mark there. And then the biggest x can be here is 1, because here is y is 2, y is 2x, so that corresponds y is equal to 1. We also remember back from here that this picture shows the biggest x could be here is 1. And so we already have, if we're doing constant bounds in x, those constant bounds have to be between 0 and 1. Okay, so now what is this curve going to be? Well, this curve right here, it should be coming from z is equal to 4 minus y squared, but so we have z is equal to 4 minus y squared, but it's also coming from y is equal to 2x. So substituting in y is equal to 2x into z is equal to 4 minus y squared, we're looking at the intersection of these two surfaces here. This gives us z is equal to 4 minus 2x quantity squared, which is 4x squared. And just a quick sanity check here. When x is 0, z is 4, great. When x is 1, 4 minus 4 times 1 squared is 0. That checks out. Okay, so z here runs from 0 to 4 minus 4x squared. Okay, so we have our bounds here. We have our bounds. Let's finish this off here. X runs from 0 to 1. Z runs from 0 to 4 minus 4x squared. Y runs from 2x to square root of 4 minus z. X, y, z, dy, dz, dx. Okay, 3 different ways to do the same problem.